blocks are, then we know a much more clear picture of what we are and where we come from. Do we know anything of that sort? I don't think we know. I don't think we have a clear picture. Well, the foundations of this theory is now shifting. The frontiers of physics is now on what is called the string theory. So, the fundamental model that we have been talking about so far, we have been talking about a standard model of particle physics. Now, what does the standard model of particle physics involve? Now, the standard model describes the fundamental building blocks and the forces through which they interact. Now, so far, our understanding of the universe is based on the standard model of the atom, the standard model of the particle physics. Now, that gives us a not very clear, but rather clear picture of the fundamental building blocks and the forces that hold them together. Now, according to this theory, there are 12 basic building blocks, and these 12 are 6 quarks. There is an up quark, a down quark, a charmed quark, a strange quark, a bottom quark, and a top quark. So there are 6 quarks, and there are 6 other particles called leptons. So according to the standard model, the building blocks of all matter are actually the 6 quarks and 6 leptons. Well, the scope of this lesson does not allow me to go any further than that, because these are very complex ideas. Now, there are 4 fundamental forces, which are gravity, electromagnetism, weak and strong nuclear forces. In fact, the whole universe is held together the way we understand it now due to these 4 forces, these fundamental forces. Force of gravity, which keeps all the planets, the stars, the galaxies, and everything in its place. And you can see the whole universe is actually in a perpetual motion. And all these are made possible by the force of gravity. Electromagnetism is a force that is responsible for holding all the particles together to form the materials that we know around us. And what are the forces that hold the atoms together? We talked about an atom as a nucleus consisting of protons and neutrons. Protons are positively charged. How can you hold a bunch of positively charged particles in a bag? Will they be stable? Well, in fact, they should all be repelling, is that right? And destroy the whole world. If that repelling comes into effect, no atoms can be stable, and the universe cannot be stable, and nothing can exist. But these strong forces are the forces that hold the nuclear particles together. Now, if you bring 2 particles that hate each other, that repel each other, and you keep them at a very small distance, that hating force, the repelling force, will turn into an attractive force. And that is the strong force. So it is a strong force that holds the nuclear particles together. Then there are weak forces. Weak forces are forces that help nuclear particles to turn from one particle to the other. There are always those conversions that is taking place. So all these forces put together is responsible for the universe as we know of now. Do you know how the gravity compares with electromagnetism? How strong are these forces? For example, if you consider 2 electrons, or an electron and a proton, the electrostatic force between them is Ke squared over R squared. And the gravitational force between them is G m1 m2 over R squared. Now, if you use the known values of these and calculate these forces, you will see that the electromagnetic force is 10 to the power of 39 times as great as the gravitational force. So compared to electromagnetic force, the gravitational force is very, very weak. So you must have a fair idea of how these forces stand. At the same time, the strong forces are very strong. The Standard Model describes the behavior of all these particles and the forces except gravity. You see, if we believe that the universe originated as a result of the Big Bang, have you heard of that theory? That the whole, everything in the universe, very many billions and billions of years ago, was concentrated at a very small point, say 10 to the power of negative 35 meter. Can you think of such a point? And the Big Bang originated from there, and ever since that time, the universe has been expanding. Now, if everything originated from there at that point, and that everything that we have is controlled by these four forces, then it is reasonable to assume that these four forces must have a single origin. In other words, we must be able to unify these four forces at some level. Now what has happened is, the theory we know, the Standard Model, has unified electromagnetism, weak and strong forces. But the theory cannot find a common link between these three forces and gravity. Now, quantum mechanics clearly gives you a way of finding a link between these three, but it has not given us a way to unify all these forces. Now, one of the reasons why Einstein was very wary of quantum mechanics. You know, Einstein did not accept quantum mechanics as it is until his death because of this particular problem. And also, he didn't believe that an electron cannot be detected precisely. Now, he couldn't buy the idea that an electron exists only as a probability value. He said God doesn't play with dice. If God created the universe, he must assign precise measurements to all these quantities. Well, we cannot spend a lot of time on this, so we need to move on. In the last few decades, string theory has emerged as the most promising candidate for a microscopic theory of everything. Theory of everything. That is, it encompasses all these four forces and all the fundamental particles. We can unify everything together under the string theory premise. Now, there are many scientists, physicists, who don't believe in string theory, whereas some others who are great proponents of it. It is based on beautiful mathematics, and it explains a lot of these phenomena very clearly. Now, it attempts to unify all existing theories about the universe. And so, it must be a formidable theory. And I urge you to spend some time finding some material about string theory and try to learn a bit about it. How it brings about this unifying effort to unify all these existing forces into a single origin. According to string theory, everything in the universe, all particles and all forces, remember we talked about the 12 fundamental particles and 4 fundamental forces. According to string theory, all these particles and forces are made up of basic strings vibrating like this. Now, these strings can vibrate in many different modes. You can see now it's not really vibrating. Now look at the mode of vibration there. This represents a different energy of vibration. So this is the same basic string, that can vibrate in many different modes. You can see that's the mode number 2, and I increase the frequency, that's mode number 3. Here you are. Not getting it right, is that right? Okay. And the string can vibrate in many different modes. So all these particles, depending on the mode of vibration, you have a different particle and a different force. Now I want you to see this here. So this now represents, well, the string had gone off the vibrator. Let me see if I can produce another mode of vibration there. There I have the 4th mode. Now each of these different modes represent a different particles. So everything that we see in the universe, all particles and all forces, are actually made up of these tiny vibrating strings, and depending on the mode of vibration, these strings can represent different particles. If one mode of vibration is an electron, another mode will be a proton, and so on. Not as simple as what I'm saying, but basically that's what the idea is. Here is another illustration of the vibrations of the fundamental string. It can vibrate in very many different modes, and a string can be a closed string like this or an open string. It can be many forms of the fundamental string. So a particle is like a note played on a guitar. You know that when we talked about the vibrations of strings, we used the same principle. When you pluck a string, it vibrates, producing a note. So one mode of vibration is a particular note, particular frequency. Another mode is a higher frequency or a lower frequency. In the same way, one mode of vibration of a string is one particle of one mass of certain energy. Another mode of vibration is another particle. So this is an ever-changing different modes of vibrations of particle. The only difference between one string and another, whether it is a heavy particle that is part of an atom or a massless particle that carries light, that its resonant patterns are different. What I showed you in the demonstration are the different resonant patterns of the string. So depending on the different resonant patterns, the string can represent either a heavy particle that is part of the atom or a particle that is massless, like a neutrino, or a light particle, photon, can be represented by a vibrating string. Now the vibrational pattern determines what kind of a particle the string represents. One resonant pattern makes it a photon, another makes it a heavy particle within the nucleus of the atom. So a string theory is actually a simplified theory that everything in the universe is made up of these fundamental one-dimensional strings. But it is not as simple as we explained. It is based on very complex mathematics. Now, what is the